Hi my dear students, once again welcome back to the classes. Today we are going to discuss the discrete probability distributions. So that's our today's section. So for that we need to know about what is the random variable and what is the probability of that one and what is the probability distribution, these things. Okay, let us discuss that things. So for a random variable, let us consider sample space, say the tossing of two coins. Okay, so the sample space are H, T, TH, and TT, right? So, and the probability of getting a head is getting two head is, it's 1 over 4. Head and tail is 2 over 4 and the two tail is 1 over 4, right? Okay, so instead of representing that, I'm going to represent the whole sample space with the help of some numbers. Let X be the number of heads, tens of, right? So what are the values that X can take? So either there may be no X, right? No head. So the X can take the value 0, means no heads. Or X can take no heads, means both will be tails, right? Now X can take value 1. That means one head, number of head is 1. So one head means either it can be this one or this one. Or X can take the value 2, means 2 head, right? Then that will be this case. So these are the only possible value that X can take when we toss two coins at a time. So instead of representing the whole sample space by this way, we can represent that X as by a number 0, 1, 2. Then let us also define the probabilities of. So let probability of X is equal to 0 means what? Probability of X is equal to 0 means what is the probability of the number of heads equal to 0? That means it is tail only, so we have that is 1 out of 4, right? And what is the probability of X is equal to 1? X equal to 1 means one head. One head can happen in this way or this way. So there are two favorable cases out of 4, so 2 out of 4. Now when X is equal to 2, it can take the value, means 2 heads. That is again only one case, 1 out of 4. Okay, so the probabilities are there. If I am going to represent that X and P of X in a table like this is X. X can take 0, 1, 2, and P of X is 1 over 4 and 2 over 4, again 1 over 4. Okay, so these are the probabilities. So if you represent that, see the same thing, sample space is expressed in terms of numbers and the probabilities are here. Okay, so if we can express the sample space and the corresponding probabilities in such a table, that table is called a probability distribution table. And this X, the X can take some values, that X is called the random variable and the P of X is called the probability distribution of that random variable. Okay, so that is the meaning of probability distribution and random variable. Now if we look at the probability distribution, we can see that the probabilities of probability values are always positive, right? And again you can see if we add up all these things, say 1 over 4, so we represent it as sigma P of X, means the sum of the probabilities, that is 1 over 4 plus 2 over 4 plus again 1 over 4, that is equal to 4. This is the same denominator, so we can add up the numerators, 1 plus 2 plus 1 that is equal to 4 over 4, and that's equal to 1. So this is the easiest way to check whether a distribution is a probability distribution or not. If it is a probability distribution, then the sum of the probabilities is always equal to 1. Okay. So that is why we define like this way. Probability distribution is the table or formula or a graph that gives the probability for each value of the random variable. So just like in the previous in the table, we saw these are the x values and the corresponding probabilities. So that is a table. So that's an example of that one. So probability distribution. And every probability distribution must satisfy the following 3 requirements. What are the 3 requirements? One is there is a numerical random variable x. Its number values are associated with the corresponding probabilities. Probability of x is equal to x. Just like in the previous example, we can see that x can take some values and the probabilities are given here. That's it. Okay. Now, what is that? Sum of the probabilities is always equal to 1. That is again, we found that one. See, sum of the probabilities is always equal to 1. And then that probability value, because it is always represent the probability, that means the probabilities are always positive. So that will always lie between 0 and 1. So that is the definition of probability. So these are the 3 main properties of probability distribution. Okay, but we mainly focus on the second probability to check whether the distribution is a probability distribution or not. We just need to check whether the sum of the probabilities is equal to 1 or not. Okay, so let us have an example like this. See, example, determine whether this table represents the probability distribution. What we want to do? We want to check whether the sum of the px is equal to 1. So sigma px. So what are the sigma px? Sigma px is 0.25 plus 0.3 plus 0.3 plus 0.15. Okay, so it is 0.25 plus 0.15, that is 0.4, plus 0.3 plus 0.3 is 0.6, that is equal to 1. Or you can input that in the calculator. So that's the way in which we can check whether it is a probability distribution or not. So the sum of the probabilities is equal to 1. Okay. Now let us have another example. Example number 2. Okay. In this case, determine the value of the missing probability if it is a probability distribution. So we have the random variable x here, the probabilities are here. So how to check whether it is, we know if it is a probability distribution, sum of the probabilities is always equal to 1. Okay. So when we add up all these things, that will end in 1. So let us add 0.35 plus 0.2 plus, we don't know that value, so we can find it out. So next one is 0.15. Okay, so it is 0.7. So the sum of the probability is always equal to 1. So it is this is the 0.7. So 0.7 plus something is equal to 1. So we know that something is nothing but 0.3, right? So 0.7 plus 0.3 is equal to 1. So this is the missing value, 0.3. Got it? Okay, now let us have the example number 3. Can the following table be a probability distribution? So how can we check whether it is a probability distribution or not? Just add all these probabilities, and if it is equal to 1, it is okay. Otherwise, it is not a probability distribution. Okay. So either let us add this, or with the use of calculator, you can do that one. I am going to add manually. So 5 plus 5, 10, 0, remainder. Yes, it is equal to 1. So that means it is a probability distribution. Okay. So that is the first thing we had learned. So what is the probability distribution, and how to find the, how to check whether it is a probability distribution or not, and what is the meaning of probability distribution. All these things are discussed. Okay. Now we are going to discuss the next important property. What is the mean of a distribution? In this case, you see this probability distribution. Here, the collection of values obtained a finite or countably infinite random variable is said to be discrete. Means the values are discrete values. So that is why it is called a discrete distribution. Because we have specific numerical values for each random variable, that's why it is called a discrete value. And if the probability means the collection values are some continuous values, it is called a continuous. Means in between the some range or like that, then it is called a continuous. So here, for example, discrete and continuous, we heard that from the first module. So the student's height, we know the student height can vary from say from a particular range to 6.3 or 6.4 or means something like that. And if you take the second case, the number of siblings, you know, the number of siblings is a particular number. So, the 2 sibling, 3 sibling, we will never say 2.5 sibling or like that. That's why it is again a discrete one. So the next thing is how to find the mean of a discrete probability distribution. What is the meaning of mean? For the distribution, the frequency distribution, it is not like that. How to find the mean is something different from that of the mean that we calculated in the previous area. So here is a specific formula for that one. How to calculate? So if we have a discrete distribution and the probabilities, then to find the mean is usually denoted by mu and is given by mu is equal to sigma x times p of x. So what is the meaning is you just multiply x1 p1 means the first one with the probability, second one with the probability, and then add up all these things. For example, if we go back to the previous problem, see in this case to find the mean or mu, you just need to multiply the 0 with this one, 1 with this one, 2 with that one, 3 with that one, and then add up all these things. That will directly give you the mean value. That is the mean. Okay. Mean is also known as expectation or expected value. Expectation of x. We will also write expectation of x. Means the expected value of x. So that is also the mean. So mean or expectation of x is given by sigma x p of x. Sigma x p x means x1 times the probability of the p of x1 plus x2 times probability of x2 and etc. So last one is, suppose we have 10 x10 into p of x10, and that will give you the mean value for the random variable. Okay. So for mean and standard deviation is also there. So mean and standard deviation. Standard deviation of a random variable can also be find out. So how to find the standard deviation? So standard deviation is given by the formula sigma square root of x minus mu the whole square times p of x. X minus mu. Mu means the deviation. And x minus mu means the deviation from that one, and square it and then multiply it with the p of x and then square root. For example, if we have say the mean and standard deviation of the following, for here this example, x is here 1 2 3 4 5 and the probability values are here. So to find the mean, what we want to do is we want to find x times p of x. That is the first column. Multiply that one, this one, this one, this one, this one, and then x minus, that is adding all these things, you will get the value of mean value. So mean is the sum of all these things, and that is equal to 3.5. And if you find the standard deviation, you want to take the deviation from the mean. So x minus mu, find out the x minus mu. You know, x is here, mu is 3.5. So x minus 3.5. And then multiply it with the probabilities. That will give you. Let us do an example with the help of GeoGebra. Okay. So let us consider this example. So we want to find the mean and standard deviation of this one. So we have the data here in the GeoGebra spreadsheet. So we can check whether it is a PDF or not by finding out the sum. So select all and click on the sum button. You will get that is equal to, say, select these things and then plug on sigma. You will get it as 1. So that means it is a PDF, probability distribution function, because sum of the probabilities is equal to 1. To find the mean value, we need to find x times p of x. X times, so p of x. So we want to input like this way. So we are going to find the mean. How to find the mean? You know, that is x times p of x. So p of x. So we are going to find out that value. Okay. So x times p of x. For that, what I am going to do is equal to. Then click on this and then start. Then click on this and enter. It is 0 times 0.25. So you will get the value there. And then move the cursor to the end of the right end of the box. Then the cursor will turn to a cross. If you reach a cross, then hold press and then drag like this up to the last cell. Then the value will automatically be multiplied and displayed there. Okay. And if you want to find the sum, select all that and then click the sum. So the value is here. So the mean is that one. So what is the mean? Mean is sigma, we know that is sigma xpx. So sigma xpx is, sigma x is here, p of x is here. So we calculate that with the help of GeoGebra and you got the value as 2. So the mean is equal to 2. Got it? In this case, the mean is equal to, this is a different problem. So mean is equal to 2. Okay. So we have a typical problem and the mean value is equal to 2. And similarly to find the standard deviation, we need to find, the formula is this one, x minus mu the whole square here, x minus mu the whole square times p of x, and take the square root of that one. So we are going to do that with the help of GeoGebra. So here what we want to do is x minus mu. So x minus mu is 2. So x minus 2. And we can find the x minus 2 the whole square there. So it is x minus 2 the whole square. So what is x minus 2 whole square? It's times x minus 2. Or we can write it's 2. Okay. So what we are going to do is first x is this one. Oh, first of all, we want to put equal to. That is the formula always start with equal to. So equal to, then put this one x minus 2. 2 is a constant. So that is the mean value. So x minus mu and the whole square. So shift cap 2. Enter. Okay. And that is, you know, what is that value? So, you know, that is 0 minus 2 the whole square. And that is 0 minus 2 is minus 2. Minus 2 square is 4. That's why that value is 4. No need to input all the other values. Just click on there and move the cursor to the right corner. You will get a cross and drag that. Okay, so the values are there. So that is x minus mu the whole square. Now the formula says it is x minus mu the whole square times p of x. So this is x minus mu the whole square. So we want to multiply it with p of x. So what we want to do is again equal to, and x minus mu the whole square is there in this column. So we just pick that one, equal to, then times shift the star key, okay, shift, okay, so x minus mu the whole square is there, times p of x. P of x is this column, okay. Oh, that disappears. Okay, equal to, again, this value, that is x, sorry, that is not the value. Go back. This value is x minus mu the whole square times p of x. P of x is this column. Okay, enter. So it is p of x is so it is p of x is 0.25. So 1 times 0.4 times 25. So I will go back to the table again. It is 4 times 0.25. Okay, so you know 4 times 0.25 is 1. That is why the answer is 4 times 0.25. It's nothing but 1. That is the value. Okay, so you go back to the table again, and again we want to apply for all these columns. So just move around here and then go to the right corner to get the cross and then drag that. Okay, so you will get the x minus mu the whole square times p of x, and we need the sum of that one. So we want to select that and click on the, so it is 1.6. So the x minus mu the whole square, so actually where we are is x minus mu the whole square times x minus mu the whole square times p of x, and the sigma means the sum of that is from GeoGebra table is 1.6. So it is 1.6. So the standard deviation means, so find the standard deviation. We need to find x minus mu the whole square times p of x, and we have already got the value. And now we have to find the square root of that. So square root of 1.6 is 0.4. So the standard deviation is equal to 0.4. Okay, got it? It is not for this problem. It is for the problem given in the GeoGebra table. And this is the problem. And you can do the same thing and verify your answer is correct or not for this particular problem. You just need to input the values in the GeoGebra table and check whether you got the same thing or not. Okay, I think that makes sense. Hey guys, that's all for the time being. We can discuss the remaining things in the next class. Okay, thank you.